So you have a coin, a fair one, no dirty tricks. You toss it, heads. You toss it again, heads. Again, heads. Again, heads. Here comes the fifth toss. Are you more likely to get tails? If you believe so, you may be buying into the gambler's fallacy. The gambler's fallacy is the mistaken belief that if something happens more frequently than normal during a given period, it will happen less frequently in the future, or vice versa. In situations where the events are truly random and independent, this belief is false. The best known example of the phenomenon occurred in 1913 when the ball of a Montecarlo casino's roulette fell in black 26 times in a row, a 1 in 66.6 million chance, assuming the mechanism was unbiased. In any case, gamblers lost millions betting against black. Because of that incident, the gambler's fallacy is also known as the Monte Carlo fallacy. One of the earliest descriptions of the fallacy can be found in a 1796 essay of Pierre-Simon Laplace, in which he described the ways some men calculated the probability of having sons. The expecting fathers feared that if more sons were born in the surrounding community, then they themselves would be more likely to have a daughter. Even nowadays, many parents still believe that after having multiple children of the same sex, they are due to have a child of the opposite sex. Some researchers believe that it is possible to define two types of gambler's fallacy, type 1 and type 2. Type 1 is the classic gambler's fallacy, where individuals believe that a particular outcome is due after a long streak of another outcome. Type 2 occurs when a gambler underestimates how many observations are needed to detect a favorable outcome, such as watching a roulette wheel for a length of time and then betting on the numbers that appear most often. For events with a high degree of randomness, detecting a bias takes an impractically large amount of time and is very difficult, if not impossible to do. There is also the inverse gambler's fallacy, sometimes called retrospective gambler's fallacy. In short, when a supposedly unlikely event happens, people tend to believe that a longer sequence of random events had happened before. For instance, people hearing that a teenager has unprotected sex and becomes pregnant on a given night will tend to believe that she has been engaging in protected sex for a while, when the probability of becoming pregnant as a result of each intercourse is independent of the amount of prior intercourse. According to the fallacy, streaks must eventually even out in order to be representative. It has been proposed that the gambler's fallacy is a cognitive bias produced by a psychological heuristic called the representativeness heuristic. People expect that a short run of random outcomes should share properties of a longer run. So yes, you, quick, give me the result of 5 coin tosses. I don't know what you produced, but I'd bet some coins that 92.5% of you guys produce a 3 tails, 2 head sequence or 2 tails, 3 head sequence. When people are asked to make up a random looking sequence of coin tosses, they tend to make sequences where the proportion of heads to tails stay closer to 0.5 in any short segment than would be predicted by chance, a phenomenon known as insensitivity to sample size. The gambler's fallacy is a deep-seated cognitive bias and can be very hard to overcome. A study in 1967 suggests that even instructing individuals about randomness and the gambler's fallacy is not sufficient in lessening the fallacy. After this video, you'll still fall for it.